Hello everyone. So today we are going to continue with the section 3.3, derivative of trigonometric functions. So last day we found the derivative of sine x is cosine x using the difference quotient. And today what we're going to do is just look at the derivatives graphically. As you can see here, we have the graph of sine x and cosine x. We're going to examine the tangent slope at various points. So here the tangent slope of sine x as x equals 0 is 1. At pi over 2, it is 0. And then at pi, the tangent slope is negative 1. At 3 pi over 2, the tangent slope is 0 once again. And finally, at 2 pi, the cycle repeats, so the tangent slope here is 1. So if we were to plot these tangent slopes that we found, we will have 1, 0, negative 1, 0, and 1 respectively. And in fact, if you found the tangent slope of all the points in between, it does form a cosine curve. So we're going to go ahead and draw that in here. Okay, so once again, if y is equal to sine x, then the derivative y prime is equal to cosine x. We can perform a very similar analysis for cosine x. Again, let's look at the slopes. We have a slope of 0, a slope of negative 1 at pi over 2, a slope of 0 again at pi, a slope of 1 at 3 pi over 2, and finally a slope of 0 at 2 pi. And of course, we can also graph those points. So we have 0, negative 1, 0, 1, and a 0 again. If we're going to go ahead and connect the points there, of course, you can see that it is a sine curve, but it is not a positive sine curve. It is a negative one. Okay. Something like this. So if here, if y is equal to cosine x, you have that y prime is equal to negative sine x. Very important distinction there. So using those two derivatives, we can find the derivatives of other trig ratios, or trig functions, using the quotient rule mostly. We start with tangent. So using the quotient identity, I know that y is equal to sine x over cosine x if it was tangent x to begin with. Then the derivative, we can use the quotient rule here. So that would be cosine x, taking the denominator, and then the derivative of the numerator is cosine x. We will subtract, and then the sine x in the numerator, and the derivative of the denominator is negative sine x. And of course, this will be all over the square of the denominator, which is cosine square x. Okay, so we're going to go ahead and simplify this a little bit. Cosine x makes cosine square x, of course. We have two negative signs, so that will be a plus sign there, and then sine square x. And this will be all over cosine square x. And for those of you who remember your trig identities, you'll notice that the numerator is in fact just 1. So you just have 1 over cosine square x, which means the derivative of tangent x is going to be secant square x. So a very neat result. Let's continue. Now we have the derivative of secant, cosecant, and cotangent. We're once again going to use the quotient rule. So for the first case, we have this is 1 over cosine x. In the second case, we have 1 over sine x. And in the last one, you can do this in two different ways. You can think about cotangent x as 1 over tangent x, or you can think about it as its own quotient. I'm going to go with, let's go with cosine x over sine x here. Use the quotient identity, just to be a little bit different. So the derivative in the first case, using the quotient rule, the cosine x, and then we take the derivative of the numerator, which is 0, minus then 1 times the derivative of cosine x, which of course is negative sine x. And this will be all over cosine square x. Oops, it's a little bit light. There we are. Okay, so this would be cosine square x. Alright, so you can see that the numerator, once you kind of simplify everything, you're left with sine x. And the cosine square x, I'm going to split it into two parts here. I'm going to rewrite the cosine square x as cosine x and then cosine x here, with a numerator 1 on the second part. So this will leave you with tangent x for the first term, the first part, sorry. And the second part, 1 over cosine x, will give you secant x. Okay, so similarly, cosecant x, you can do the same thing. So the derivative, of course, of cosecant x, we can use the quotient rule. So sine x and the derivative of 1 is 0, just like before. If 1 and the derivative of sine, of course, is cosine. Sorry, sine x is cosine x. So all over, oops, that's the wrong color. So all over sine square x. Very similar to the previous question. With an important difference, and that is there's a negative sign involved this time. So we have negative cos x over sine x, and then 1 over sine x. So we can split up the terms just like before. And this will leave us with y prime is equal to negative cotangent x and cosecant x, like so. Next one, very similar. The derivative here, let's take the derivative of, so we actually leave sine x as is. The derivative of cosine is negative sine x minus then the cosine x just as is. And then the derivative of sine x, which is cosine x, using the quotient rule. And this will be all over sine square x. Okay, so you'll notice that both terms here are negative. So you can factor out a negative sign and then combine the sine x's and the cosine x's. And here you will have sine square x, of course. And now, because you factor out the negative, a plus sign, cosine square x. And this will be, once again, all over sine square x. Alright, so just like before, using the identity, this is equal to 1. So you just have negative, this is y prime, negative 1 over sine square x. So y prime is equal to negative cosecant x, square x. Okay, kind of what you expected. Maybe did not expect the negative sign, but it is there. So that's a lot to remember. And there's, luckily for us, there's a nice mnemonic device for remembering these derivatives. So it's PSST. And how's that work? Well, if you line these up correctly, the derivatives, And the original function, we have y, oops, sorry, that's a little too light. All right, y equals secant x, and its derivative is equal to y prime is equal to secant x tangent x, and also the derivative of tangent x is equal to secant square x. So here you can see s, s, and t, and likewise we have t, oh, sorry, that's a t, t, and then s and s. And likewise for the cosecant, y equals cosecant x, and its derivative is negative cosecant x cotangent x. And once again, you have here s, s, and t. And then likewise for the derivative of cotangent x, you have negative cosecant square x. And that's also t and then s and s. So a nice way to remember the derivatives. You can also think about it this way. Secant gives you secant and tangent, and then tangent gives you secant and secant. And likewise, the derivative of cosecant gives us negative cosecant and cotangent. And then the derivative of cotangent is negative cosecant square. Okay, let's write this again, just make it look a little bit nicer. There we go. So the application of these derivatives, just taking some derivatives here. Let's clear quickly. So the g prime of x would be the derivative of secant x, of course, is secant x tangent x. And then the derivative of cotangent, of course, is negative cosecant x. Cosecant square x. And then you can simplify the expression by combining the two negative signs. So you have 3 secant x tangent x plus 10 cosecant square x. Next up we have, one where we have to use a product rule. That's good. So the product rule is going to take y prime here. So 5 we're going to leave it in front. So the product rule means that we take the derivative of the first part, which of course is cosine x, leave the cosine x as is, and then plus leave sine x as is, and then take the derivative of cosine x, which is negative sine x. All right, that's the product part. And then the derivative of cosecant x, of course, is negative cosecant x cotangent x, just using the mnemonic device from above. And then you will notice here that you have cosine square x minus sine square x, and then minus 4 cosecant x cotangent x. And finally, you can apply the trig identity, and so you have 5 cosine 2x minus 4 cosecant x cotangent x. So nice tricky part at the end there where you have to apply um, the trig identity for double angles. So one more. Okay, so it's best to rewrite the function. So we have 3 and then w to the negative 4 and w squared tangent w. So we can apply the power rule easier without, like, we don't want to use the quotient rule here because that will be too much work. So the derivative of this one, that will be negative 12 w to the negative 5th power. And then the second piece here, the w squared tan w, you can use the product rule. So you have 2w tangent w plus w squared secant squared w. And of course, you can simplify by multiplying things out and writing this without negative exponents. So you have negative 12 over 5, sorry, w to the 5th power minus 2w tangent w minus w squared secant squared w. That's it. So some of you were asking about what happens if you have, let's say you want to take the derivative of cosine 2x. That's going to be involving what's called the chain rule, which is the next part. For right now, we have the derivative of all the trigonometric functions covered, and that's it for today. So thank you for listening.